the current PPTs, we will now discuss about the preparation of alkyl halides. So this preparation could be both the manufacture of haloalkanes and haloarenes. So these compounds can be prepared by three major methods. First method is from alcohols. Second method is from hydrocarbons, and the third method is from halogen exchange method. I repeat, the first method is preparation of alkyl halides from alcohols. Second method is from hydrocarbons, and third method is from halogen exchange methods. So in the first method of preparing alkyl halides from alcohols, so probably this is the best method by which alcohols are used for the preparation of alkyl halides. And this method seems to be easily accessible because the hydroxyl group or the OH group of an alcohol is replaced by halogen on treating with concentrated halogen acids, phosphorus halides, or thionyl chloride. Amongst this, thionyl chloride is preferred because the byproducts are found to be in gaseous state and they can easily escape from the preparation medium. Hence, the reaction gives a pure alkyl halides which do not need further purification. So here the next slide we are studying when an alcohol, that is ROH, plus an halogen acid. So halogen acid can be hydrogen chloride or hydrogen fluoride, hydrogen bromide, and hydrogen iodide. In presence of zinc chloride, we get the alkyl halides and water. So the OH group is easily removed and replaced or substituted by X and halogen. The second method is an alcohol plus sodium bromide in presence of sulfuric acid, concentrated sulfuric acid. We get the alkyl halide, that is alkyl bromide plus sodium bisulfate and water. Sodium bisulfate is formed as a precipitate and it settles to the bottom. Thereby, the purification takes a long process. The next example, alcohol when it is treated with a phosphorus halides, that is, it can be phosphorus pentachloride, phosphorus fluoride, phosphorus bromide, or phosphorus iodide, which can be easily accessible for the formation of an alkyl halide, that is RX, and a phosphoric acid, that is orthophosphoric acid. So alcohol plus PCl5, in a specific example ROH and alcohol plus phosphorus pentachloride will give us the alkyl chloride plus phosphorus oxy trichloride and HCl. POCl3 plus HCl escape as gases, and purification needs no further processing. Or alcohol in presence of red phosphorus and halogen, we get alkyl halides, but the use of red phosphorus is little dangerous. So in the next example, an alcohol ROH when heated with thionyl chloride, that is SOCl2, thionyl chloride will give an alkyl chloride plus sulfur dioxide SO2 and hydrochloride gas. So SO2 and HCl are gases and they easily escape from the system. Thus, the alkyl halide produced needs no further purification. So these reactions of primary and secondary alcohols with an alkyl halide, hydrogen halide, that is HX, requires the presence of a catalyst, that is zinc chloride. So the reactions of a primary and secondary alcohols when they are treated with halogen acids, they generally require a catalyst like zinc chloride, while tertiary alcohols, the reaction is instantaneous at room temperature and they do not need a catalyst. So the above methods are applicable only for the preparation of haloalkanes and not applicable for the preparation of haloarenes because phenol has partial double bond character and it is difficult to break a double bond. Rather, more energy is required to break a double bond. That is, compounds, that is, benzene like compounds, when they are treated with halogen acids like phenol, the haloarenes are not formed is because the double bonds cannot be broken down. The second method, as we have already mentioned, it is from hydrocarbons. So the second method, manufacture or preparation of alkyl halides from hydrocarbons. So here we have four different methods. The first method is through free radical mechanism. Second method is through electrophilic substitution reaction. Third method is Sandmeyer's reaction, which is very important. And the fourth one is from alkenes. So, under the manufacture or preparation of alkyl halides from hydrocarbons, the first method is by free radical mechanism. So, the above mechanism we can get only a mixture of isomers and the process also takes a long time. So, this free radical mechanism we have already discussed in our previous, that is 11th standard, that when a hydrocarbon like methane reacts with chlorine in presence of sunlight, we get methyl chloride or chloromethane plus HCl. And we also do get ethane as the byproduct. So the halogens can replace the hydrogen atoms one by one, thus forming chloromethane, dichloromethane, trichloromethane, and tetrachloromethane. That is CH3Cl, CH2, Cl2, CHCl3, and CCl4 along with CH3CH3 ethane. This we have already discussed in the previous year as the first reactions while studying the homologous series of alkanes. Fluorine compounds cannot be prepared because they are so fast, the reactions are so fast that their isolation is difficult, and bromine compounds cannot be formed because of the very slow reactions. They need high temperatures, catalyst and pressures, and iodine compounds are not possible because most of the iodine compounds do form the reversible reactions. The second method is by electrophilic substitution method. Probably this is the method generally used for the preparation of aryl halides. So arenes, that is compounds containing double bonds, when they are treated with chlorine or bromine in presence of either iron or iron chloride catalyst, ortho and para isomers are obtained which can be separated easily. The orthoisomer and the para isomers do have a large difference in their boiling points, and thus they can be separated by the distillation method or the distillation process. The third one is the Sandmeyer's reaction. So this reaction is very important, and this is generally named after the scientist Sandmeyer, who had prepared or used this for the first time. So here, when a primary aromatic amine, if it is dissolved or suspended in cold aqueous mineral acid, is treated with sodium nitrite, a diazonium salt is formed. So mixing the solution of freshly prepared diazonium salt with cuprous chloride or cuprous bromide results in the replacement of diazonium group by chlorine or bromine. So in the below example, this is C6H5NH2. This is commonly known as aniline, and the IUPAC name is aminobenzene. So aminobenzene, it is cooled in ice cold bath, to which a solution of sodium nitrite, that is NaNO2, and a halogen acid or a mineral acid, that is HX, where the temperature is 0 degrees. That means both the solutions, that is solution of sodium nitrite and solution of HCl or a HBr, are cooled to 0 degrees, and they are mixed together, where we get a intermediary product called the benzene diazonium halide. Benzene diazonium halide. The hydrogen of the amino group is replaced by the halogen, and this compound, if it is treated with cuprous chloride or cuprous bromide, the nitrogen is replaced completely by this excess of halogens present, thus giving us aryl halide and thereby liberating nitrogen. So this reaction is also practically studied, and these are the questions that are asked for the viva in practical exam of second year board exams. So this is Sandmeyer's reaction. Fourth one is from alkenes. Fourth one, alkenes. So alkyl halides can also be prepared from alkenes by adding halogen halides and halogens, which we have again discussed them in our 11th standard. So this type of addition always follows the Markovnikov's rule, and the product formed is also known as the Markovnikov's product. So the Markovnikov's rule says that if an unsymmetrical reagent, that is like hydrogen bromide or hydrogen chloride, adds to an unsymmetrical alkene. An unsymmetrical alkene, the product formed is always the 2-degree product as the major product. Example, if a hydrogen bromide is added to propane, the product formed is always 2-bromopropane. That is the positive part of the reagent, that is H plus of either HCl or HBr, will always add across the double bond which has more number of carbon atoms. So this is Markovnikov's rule, and thus the product formed is always a 2-degree product, that is the major product form. This is what the Markovnikov's rule. The last one is by halogen exchange method. So alkyl iodides are often prepared by the reaction of alkyl chlorides or alkyl bromides with sodium iodide in acetone, and this reaction is known as Finkelstein reaction. The reaction is known as Finkelstein reaction. That is an halogen halide Rx, that can be a chloride or a bromide. If it is treated with sodium iodide, we get alkyl iodide and the sodium halide. So this reaction is Finkelstein's reaction, and the alkyl chloride, the alkyl bromide, that is sodium chloride or sodium bromide, formed as a byproduct, is precipitated out in acetone. That is, when we dissolve it in acetone, this NaX get into acetone. So the synthesis of alkyl fluorides is best prepared by heating an alkyl chloride or bromide in the presence of a metallic fluoride. In the presence of a metallic fluoride such as silver fluoride, mercuric fluoride, cobalt fluoride or tin fluoride, and the reaction is named as Schwarz reaction. The reaction is named as Schwarz reaction. So in the example below, CH3X, where X can be a chloride or a bromide, if it is treated with silver fluoride, we get CH3F, that is an alkyl fluoride and a precipitate of silver halide which can be filtered off.